is Mojave Cement Plant. Nearly 1.5 million tons of cement shipped out by rail and truck. Our electricity supply is Southern California Edison, and it is, in addition, what we're going to talk about today is our wind turbines. Our wind turbines are, we have a purchase power agreement with 24 megawatts of wind capacity that plugged into our plant. We're going to talk about that. And, go up there and look at the turbines and discuss their operation. That was the substation we just passed by. And here we are coming into the entrance to the plant. Today, I'm in the Mojave Desert near Mojave, California and Tehachapi, California. CalPortland has a cement plant, the Mojave Cement Plant. We have, right behind me, what you see are wind turbines that are up here. The area has a very good wind resource. There are hundreds of wind turbines operating in this area. CalPortland has a purchase power agreement with 8 wind turbines that directly feed into our cement plant. That's 8 3-megawatt Vespa wind turbines. The ones behind me that you see that are spinning right now, we have a little bit of breeze going on and some power is being generated. And just over my left shoulder, kind of in the center, down in the valley area, you can just see the top of the cement plant poking over that ridge there. And all this wind generation is going through its own individual power line right to the substation in our cement plant, directly feeding our electrical equipment. Today, this is September of 2020, so the region is very smoky right now, so it's hard to see down there. There's a lot of haze and there's this smell of burnt smoke in the air due to all the wildfires in California right now. So I apologize for the poor the haze and view, but trust me, the cement plant's down there. And this morning when I got here, the wind wasn't strong enough, and typically there's a daily increase in wind as the day progresses, and the afternoon and evening is when most of our wind is generated. Then it starts to taper off later, and as the sun rises, there's pretty much nothing, and then once again the cycle begins. About 20% of our annual electricity is coming from these wind turbines to this cement plant. 20% of our electrical consumption is renewable, zero carbon, and actually very economical too. Currently we're working on an interconnect agreement with Southern California Edison. At times we would like to be able to export this power. We have this renewable power that we can get onto the grid, and it's an arduous process, and we're in the middle of it, and we're getting closer every day, and it'll be exciting when we finally do get to when the time is right. We have the ability to potentially shift mills, reduce load at certain times, and then if the wind's blowing, and then if our production schedule matches, we would be able to export power and supply grid power from our turbines, just like the rest of these turbines around here are doing in the California environment. So, thanks for stopping by and seeing what we're doing. Remember, energy and industry. So this is the separate angle, more in front, looking at the front of the wind turbines. Like I said before, we have 8 of these 3-megawatt Vespa wind turbines. Each one is, next to each other. There's a 3-phase distribution line going down to our substation, feeding, right together with the Southern California Edison substation in parallel, feeding it whatever power we get from Edison. And as the wind turbines pick up generation, they're offsetting that import power from the Southern California Edison's transmission line. The 3-megawatt turbines, they have a SCADA system that's controlling it, and since currently we cannot export, there are reverse power trips that if these relays sense generation or the attempt of generation out in the grid, which is right now forbidden, these relays will trip the feeder breakers from the wind turbines to the plant. And so what we have to do is, and what TerraGen has to do, the operators of the turbines, they have to closely monitor the plant load, closely monitor our generation from these turbines, and as they approach that trip set point, if there's enough wind, and there's a bunch of wind, and if our load's at the right point, we're going to start approaching the trip set point, and they can reduce the generation from these generators. Each of the blades rotates, and you can kind of, when you look real close at it, you can see then there's a bearing that it rides on, and as those blades are rotated, it takes them in or out of the wind path, to pick up that wind. I think the term they use is feathering. So you feather those blades and reduce that generation. We want to consume as much as possible, but we don't want to trip the relay. So there's a constant balance of looking at that load and trying to get as close as you can, but not so close. And unfortunately, the set point is not zero. It's way above zero. Engineers, they like to be conservative, right? They don't want to ever violate. And so it's 1,250 kilowatts above that 0 point. So realistically, we're losing out on 1,250 kilowatts of generation from our 24 megawatt turbines. And it's a frustration. We want it. We want that power. But because we're limited by Southern California Edison for generation, for exporting, we got to have these set points in and minimize our renewable generation. This is actually it's a transmission problem. This is the whole state's going to have to really look at the transmission and how much they're going to have to invest a lot. They know that. They're already, the utilities are investing a lot. When these turbines were first installed in 2006, the local infrastructure absolutely could not take this extra generation. But then they built a brand new substation. It's called Wind Hub. It's a very large substation, Southern California built. It's on our property. We sold them the land. And so now you got this large substation, and then the population of wind turbines exploded at that point. And we're just in the bureaucratic administrative process of trying to get in and plug in and be able to, we're plugged in already. We're part of that system. It's just they're providing us power. We want to be able to just reverse course and push out. And it's just it's a long process to get all the paperwork and the system in place. And hopefully soon we want to be able to, at some days, if it's really windy and we have the capacity, we can export. So I just wanted to give you a view of these beautiful turbines. You probably noticed, somebody's going to notice, they're 1, 2, 3, the third one over is not moving. So something's wrong with that turbine, and this is a problem that it happens. These things fail, something happens, and maybe they're doing maintenance, something, and so that 3 megawatts is at full capacity, right? This thing varies based on wind. It's not operational right now. When I drove by, I saw a technician. He had the bottom hatch open, and whatever he's doing in there, he's trying to work and get it running again. I hope, because we would love to get that power from that turbine. And so I just wanted to point that out, that one's not spinning because it's faulted right now, and they're trying to get it back online for us. Well, I'll let that be, and we'll continue our little adventures in energy and engineering and see what else comes across our paths. Thanks a lot, Bill Gerald.